Determine algebraically whether the functions are inverses of each other. To do that, one way is we can say, let's start with one equation, switch x and y to find the inverse, and see if it matches up with the other equation. So if I were to do that, well, I'd switch x and y, move the 6 over, and divide by 3. So that would be the equation of my inverse. Does that match up with the one they've given us? The one they've given us has a negative in there, so we can say no. These are not inverses of each other. In the second one, we can do the same thing. Here is the equation that we start with. If I switch the x and the y, move my 3 over, multiply by -1, and then square root both sides. When I square root negative x plus 3, do you see that negative x plus 3 is the same as 3 minus x? And I'm only writing it that way because I want to think about this matching up here. Now, in my original equation, they gave us a restricted domain. X is bigger than or equal to 0. That means when I switch the x and the y, my graph here, my y values have to be bigger than or equal to 0. And since my y values are bigger than or equal to 0, which one am I going to take? The positive one or the negative one? The positive one. Does that match up with the one they gave us? Yes. Part B says to verify the answers graphically. So what we would need to do is take out a graph for the first one. We're going to graph y equals 3x minus 6. So that has my original graph I'll do in blue. It has a y-intercept of 0, -6, a slope of 3, so I'll go up 3 over 1, up 3 over 1, and draw our line. For my second graph that they gave us was x minus 6 over 3, y equals x minus 6 all over 3. I can rewrite this, divide each thing by 3. X over 3 is the same as 1/3 x. -6 over 3 is same as -2. So when I label these points, I'm going to have a y-intercept of -2, a slope of 1/3, so I'll go up 1 over 3, so I'll be at 3, -1. Sorry, I labeled this point 0, -2. Up 1 over 3, up 1 over 3. And the second graph looks like this. To verify it algebraically, does it look like, if I draw y equals x, does it look like the blue graph has been flipped over the diagonal line to match the green graph? No. Does it look like I've taken a point and switched them? I have 0, -6. I have 6, 0. I should have -6, 0. So we can see it graphically why it doesn't work. For the second one, My original graph I'll do in blue, negative x squared plus 3. That's a parabola. Flip down and then translated 3 units up. So I'm going to have my vertex at 0, 3. And my domain is restricted just to have my x values bigger than 0. So I'm going to go over 1, down 1, over 1, down 3. But I only have this part of my parabola. And the equation that I'm trying to graph in green is the square root of 3 minus x. Now, using transformations, this seems a little bit backwards. Usually we have our x first and our numbers afterwards. So I'm going to just rearrange this a bit. Can you see that that's the same as that? Negative x plus 3. So that negative is a horizontal reflection. The 3 is a horizontal translation. What do we have to do every time we have a horizontal reflection, stretch, or compression with a horizontal translation? This is the part you're going to forget. We have to write that in factored form to do our transformation. So I've got to do it one more step, take the negative out in order to graph it with transformations. So this is going to be a square root graph. That square root graph gets flipped which way? The negative's inside is going to be a horizontal reflection and then shifted 3 to the right. So we're going to get this point, and this point. When we look at this one and draw our diagonal line, y equals x, do they look like reflections over each other? Yes. Do our points seem to match up that have been switched? Yes. So we can see graphically that this one is an inverse of the other one. For our questions for this one, which are 7, 8, 11, and 13, 11 and 13 are examples of questions where you have the tools to be able to solve them, but the wording is different than the examples that we've done so far. So you're going to have to add some extra thinking when you do questions 11 and question 13. On your final exam, on your provincial final exam, there's always a few questions that the wording is different. You have the tools to be able to solve them, but the wording is different. So these ones are good practice that way. Can you problem solve and try to figure them out?